Okay. Hello guys, you're welcome to my channel. Now right here in this video we'll be solving the integral of 2 over the derivative with respect to x of arch sine x, or it's a sine inverse of x over 2 with respect to x. First of all, you need to know what the derivative of the arch sine of x over 2 is. Now the derivative with respect to x of arch sine of x, the general case, okay, gives us, when you evaluate this, it gives us 1 over square root of 1 minus x squared. Okay, that is when the angle right here is just x. So in this case, I'm having x over 2. First of all, let's deal with our integrand because that is very complex. Okay, so in this case, we're having x over 2 here. We just put x over 2 in here and we square that. That is to say, x over 2 here will become x over 2 squared, just like that. Alright? And if we go ahead and evaluate this, putting it right here, we're going to have, first, let's deal with the integrand before we bring in the integral sign. So we have 2 over, now this alone is this, 1 over square root of 1 minus x over 2 all squared. Great. Now, I believe you know that this here, x over 2 all squared, is just x squared over 4. So this will become 2 over 1 minus, or 1 over, now we have it to be square root of, now if we have here to be x squared over 4 in this square root sign, that's as a radicand. We have 1 minus that as a radicand. You can go ahead and take the LCM on both sides. We have 4 minus x squared over 4 inside the square root, alright? Great. And if we just take the square root of that, that will become the square of the numerator and the square of the denominator. So we have square root of 4 minus x squared over 2. Isn't it? It is, right? So we can just go ahead and plug in square root of 4 minus x squared over 2 in the denominator like that. And we will have it to become, this is just the square root of 4 minus x squared over 2. Now, this is the numerator, which is just like 2 over 1. And this right here is the denominator. So we can just get it to be the denominator of the numerator. And we can write this as 2 over 1. That's the main fraction, alright? From the question, that's the main fraction. Can have it to be 2 over 1 to be, the one will come down right here. And the whole of this will go up. We multiply like that. That's what we do in division of fractions. The denominator of the numerator comes down, and the denominator of the denominator goes up. We have it to become, I was using it to illustrate something, so I can just clean it up and manage some space. We have it to be 2 times square root of 4 minus x squared over 2. You know, this comes up here, alright? All divided by 1. So this and this just goes up to 1, and the product of 1 with any number doesn't change that number. So that simply means that our integrand has reduced to square root of 4 minus x squared. That's it right there. How? Are we doing something bad? Well, let's just plug in there and see. We have it to be square root of 4, let me use black for that. Square root of 4 minus x squared dx. And that's it for now. So this is just like this in this form. Wow. Is this integration even possible? Yes, it has an elementary antiderivative. But how do we get on with it? Well, we are going to employ some techniques of integration to see if we can get this, alright? Now the main problem here in this integral, is the square root sign. If we can get rid of the square root, maybe we can employ other techniques. So what technique do we use to get rid of the square root? Okay, to get rid of a square root, we basically need to get a perfect square as a radicand. So that if a perfect square is the radicand of the square root, we can just get something great, alright? In this case, it's a function, So we're not going to say, okay, let's take solid form of it. It's just a function, so we need to factor this function. Alright? But factoring this function, where the coefficient of x is 0, if we add the square of half of that to both sides, it doesn't change anything. Because the coefficient of x right here is just 0, doesn't make sense. It doesn't change anything. We can employ another technique. What we are saying, let's go down with some substitution. Well, what would that substitution be? So that we have 4 here, and we have x squared here, difference of 2 squares. If I make my x to become 2u, like that, so that if I plug in x squared, would become what? 4u squared. And that means that our u is equals to x over 2. We know this. That our u is x over 2. Well, x squared will be 4u squared. How about changing this? The derivative from the x to the u. We will have our dx to become, derivative of 2 is just 2 du. That's it. So we can go ahead and plug in this right there, or we go ahead and substitute u. That's the u substitution. So we get on with x. Now the square root of 4 minus, where our x is just 2u. Our x squared is 4u squared. So we have 4u squared. The x is 2 du times 2 du. Alright? Nice. Now we have a product with a constant. So we take the constant to the front of the integral sign, and we have it to be 2 times the integral of. Now inside this square root, we have 4 and 4. So we can factor that out. Very good. And 4 is even a perfect square. We will have it to be 1 minus u squared du. Again, we are okay with this, where we have 2 times the integral of square root of 4 times 1 minus u squared, where 4 is a perfect square, so we can take the square root of 4, which is just 2, alright, and we will have 2 times the integral of 2, now the square root sign, let me use that in red, square root of 1 minus u squared du. And now we have, 2 is just here. We can take it to the front of the integral sign. Great. Let me just bring it down. And we will have it to be 4 times the integral of square root of 1 minus u squared du. Like that. Oh. Look at this. We haven't still taken care of the square root sign. We wanted to do that. Why here we're having 1 minus u squared? Well, we can observe, or we can think of a trig identity of the sine or cosine angle, where we have 1 minus sine of square angle is equals to cosine of square that angle. Now cosine square, let's say theta, in this case, cosine square theta is going to become, the square of cosine square theta is just cosine theta. Alright? So we can actually get a perfect square in here if we go on to substitute sine theta for u. So let's just do that. Let's say that our u is equal to sine theta. Then the u will become what? Cosine theta d theta. Okay? Great. Now right here, if you just plug in that for that, we will have 4 times the integral of square root of 1 minus sine square theta. Here that 1 minus sine square theta is going to give us cosine square theta, which is actually a perfect square. Okay, that will be very nice. Alright, and remember that the u is just cosine theta with the theta, so we just plug in there for the u. We have cosine of theta d theta. So we can go on this part of the board. So we just have it to be 4 times the integral of, now since 1 minus sine square theta is going to give us cosine square theta, okay, and the square root of cosine square theta is just cosine theta, and cosine theta times this is just cosine square theta. Cosine theta times cosine theta, we can just have it to be cosine of square theta and d theta. So we've done two substitution. The first was the u sub and the second is the trig sub. That's sine of theta. Now here it's obvious the integral right here, okay? I believe you know what the integral of cosine square theta is. Well, for us to be on the same page, let's go ahead and integrate this. But first, I have to rewrite this. There's actually a trig identity for this, which is easier to get on with. Like cosine square theta is the same thing as saying, let's just write this identity for you guys. It's the same thing as saying half of 1 plus cosine of 2 theta. If you evaluate cosine 2 theta and you substitute 1 minus cosine square theta for cosine theta, you're going to have 2 of this equals to 1 plus cosine 2 theta. Then half of that, just half of both sides. Great. So we just plug in there. We have 4 times the integral of 1 over 1 plus cosine of 2 theta d theta. You know, we are not doing substitution, so we're just doing a trig identity, not the other substitution where we have to change this. So this here remains this because this is the same thing as this. Alright? Now since we have a constant multiple, we can take it to the front of the integral sign and we'll have it to be 4 divided by 2, that's just 2. 2 in the front times the integral of, now the integral of 1 with respect to theta is just theta. Well, let's just do it step by step. I'll have 1 plus cosine of 2 theta d theta. Just mixing these things. So the integral of 1 with respect to theta is just going to give us theta. And the integral of cosine 2 theta with respect to theta, I hope you know what that is. Okay, it's just positive of sine of 2 theta over 2. Well, let's just do it on our head. If we have cosine 2 theta, well, let your w be equal to 2 theta, so that the w become 2 d theta. So that means the theta will become w over 2. That's the w over 2. Great. This is the 2 right here. So we'll be having sine of cosine of w. So the integral of cosine w is just positive sine w. Sine w. With respect to w, we have that. Very simple, right? You can just try this on your own. Do use a w sub, any variable you want to make use of, to be 2 theta. Then you go on and evaluate that. So right here we'll be having 2 times theta plus sine of 2 theta. Are we done? Well, if you are done, we just put in plus c. But well, the question right here, I've reduced it, was given in the x function, the function of x. So since we are having theta, if we want to integrate this, if we want to differentiate this, assuming these are antiderivative as a result, well, if you want to differentiate this, you're having a function in terms of theta, which is not what was given, alright? So we need to take this to the x function. And that will be by doing a backward substitution. Now looking at here, what was our theta? Well, our theta came in from u equals to sine theta. So to actually get theta from here, what do? We can take sine inverse on both sides. So if we take sine inverse on both sides, so we have sine inverse of u would be sine inverse of u was here, would be sine inverse of sine theta. That is just theta, alright? Sine inverse of sine theta is just theta. No need for much. So we just have the theta. So sine inverse of u is theta. That means in place of theta, we can just put sine inverse of u. Well, the question wasn't even given in the u form. It was given in the x world. So we need to get back to that x variable, or x function. So where our u, I stated it to be x equals to 2u, and our u is x over 2. So in place of u, I can just plug in the x over 2, and we're having sine inverse of x over 2 to become theta. So in place of theta, we just put sine inverse of x over 2. Alright? Great. So we just have here 2 times sine inverse of x over 2. Now, knowing that sine 2 theta is 2 sine theta cosine theta, we have plus 2 sine theta sine inverse of x over 2 cosine theta. Cosine theta is sine inverse of x over 2. So let me bring this line for us. So theta is just sine inverse of x over 2, like that. And now we have this, and we have this. Well, we can just simplify this, all right? We can simplify that to have a unique form. So I clean this for us. It's just the solution or the steps we took. So we don't really need it, all right? No, we need it. Without it, we can't get here. Okay, so we have this. Now observe here that sine inverse of a value is giving us an angle. Okay, and sine of that angle will give us the value back. So we have 2 sine inverse of x over 2 plus, like I said, 2 times sine of sine inverse of x over 2 is x over 2. Very nice. Like that. And we have times cosine of sine inverse of x over 2. This is an appreciable form, okay? Where this and this just gets away, and we have 2 sine inverse of x over 2 plus x times cosine of sine inverse of x over 2. Well, I don't like it like this. Cosine of sine inverse of x over 2. Well, let's get something, all right? Let me say this. We're having a rectangle triangle, and we were having our theta as an angle, and we saw that u was equal to sine theta. So that simply means sine theta would become opposite u over hypotenuse. Here the denominator right here is just 1. So sine theta is just u over 1. That's just u. Sine theta is u. What will become of our other side? Well, it's just going to become square root of the hypotenuse, square of the hypotenuse minus square of this. That is 1 square minus u square. Where our u is what? Where our u is just x over 2, we can have it to be x over 2 in place of u. We can just have this to be x over 2, like that. So bringing this back to that form, we'll have cosine of theta, cosine of theta, where this is theta, theta is equal to sine inverse of x over 2. So cosine of theta is said to be what? Adjacent over hypotenuse. That is just x, which is gotten from here, times cosine of theta, where theta is this. It's going to give us, like I said, square root of 1 minus x over 2 all square. Alright? That's okay. So we can conclude that our answer is now, or our solution is x over 2 plus x square root of 1 minus x over 2 square. Like that. Plus c. If you like, you can go ahead and evaluate this radicand, but it's also a nice place to stop. So that is what you get. Thanks for watching. Please subscribe to this amazing channel.